Sorry about that. Stop converting. I ended the meeting on the other computer and it ended the meeting for everybody. Sorry about that, guys. Okay, sorry about that. Like I was saying, my computer overheated and shut off, so I've got it moved off of the server now. You see all my junk on the floor. I guess that's good that this laptop shut itself off before it melted or caught fire. All right, as I was saying, what I'm going to do is kind of walk you guys through starting that assignment online. The networking assignment, the subnetting assignment. If you haven't started it, you need to start it or you're going to get very lost on exam 2 because that's 25% of exam 2. I spent one whole day on it, and if you missed that class, I guess that's pretty bad. But so if I record this, when is it due again? It's going to be due the day that the exam 2 is going to be made available. When is exam 2 going to be made available? I don't know. Probably pretty soon because we've only got chapters 6 through 9 on it. We've already gone through 6 and 7, and we're halfway through 8 because 8's very short. Or we didn't actually even start 8 yet on. In the 2:30 and the 4 to 5:30 that short. Anyway, let me pull this up. Network game, subnetting, assignment. Okay, let me see if I can go into student mode here. Okay, somebody's laughing. You're not allowed to laugh. No, I'm kidding.
Oh, my bad, my bad.
No problem. Okay, do you guys see the screen? Move this back over here. Get rid of that stupid avast warning. Blow that up. I wish Zoom remembered your, Zoom does not remember your previous settings, like where you set the windows at and all that. That would be nice if it did that. Damn it. Excuse me. It does some things I don't like. Okay, so here's a subnetting assignment. I'm officially doing the online version. Let's see, I need to go into student mode here. Okay, so let's just read through this real quick. Can you guys all hear me okay? It's not choppy today, right? It's because I hard-coded the computer. Who's a goof? I'm a goof? Or good? Okay, good. I might be a goof, but don't tell me to my face. An internet provider has control of a Class B address space. So first of all, what's a Class B? That's where the first 2 octets, those are called octets. Make sure you know that term, O-C-T-E-T, are the same, and the next 2 of the 4 octets are variable, and they have control over it. That /16 implies that. That implies that 16 of the 32 bits of the IP address space is fixed, and the other 16 of the 32 bits is variable, and I can make them whatever I want. Okay, so first of all, you guys understand that concept? 32-bit IP address space and what that /16 is. Okay, so the address needs to be broken down into smaller subnets for several different customers. Listed below are 10 clients, 10 different customers, which could also be 10 different departments at a business. You need to first rank each company based on their projected growth needs and do them in that order, not in order of how they're given. And the exam 2 is also going to be the same way. You're going to be given several questions. Some of them you need to do out of order. In other words, you need to do part A of all of them. Fill out the subnet table from largest to smallest. You'll need to determine the size of the subnet block needed for each customer, the net mask, calculate the projected needs, accounting for the gateway address. Don't waste space. Show your work. Okay, so let's scroll down. Let's take a look at the first one here. MySpacebook.com is denoted by an M. There's the chart I'm given, and you're going to fill out this chart. I've broken it down into little blocks of 16. Each one of these lines is a full class C. So there's 129.7.0.0. Here's 129.7.1.0. .2.0, .3.0. Do you guys all understand what you're looking at here? It actually scrolls off the screen a little bit to the right here, but it's each one of those lines is 256 spaces from 0 to 255, and each one of these blocks that you could put something in happens to be 16 addresses. Okay, we got everybody on board with that so far? What you're going to be putting in those blocks is the corresponding letter here of the organization to indicate that you're reserving that whole block for MySpacebook or Japanese. So you might potentially be putting an M there, for example, okay? So let's scroll past that. It says MySpacebook needs 480 addresses, not including a router. So they really need 481 with a 25% growth. Fill in the table below. Oh, actually, you know what? I need to change this to student view because this is not exactly what you guys see. You know what I mean? Oh, yeah, it is. Yeah, it is. Excuse me. I'm sorry. I couldn't see those little, they were drawn so narrowly. Okay, so company ranking 1 to 10, most to least. So the first thing you need to do is on all of these. Go to the second box here, projected IP address needs. What are my projected needs? I want you to count in this case for 25% growth, so that's 480 times 1.25 equals what? What does that equal? If you're lazy like me, or you've gotten lazy due to technology, you're going to use calculator program. Where's calculator? Yeah, 600. I was trying to bring up my calculator, but I can't see it. That's all right. It's I'm learning how to use Zoom here, and Zoom is covering over some things on the screen that I can't see. Oh, there it is. Quickly learning that I don't like Zoom. .480 times 1.25 equals 600. Good. So I'm just going to write 600 over here. That's your projected needs. Now I'm going to skip that. Go to the next one. Projected technologies. Oh, that's my company. I need 50 addresses with a 25% growth. What's 50 times 1.25? Equals 62.5. So what do I put in that box? Do I put 62.5? You can turn your mics on if you want, or you can type it in the chat window. It is not 62.5, it is 63. And that's because there's no such thing as half a computer. In other words, if you need to provide space on an airplane for people, just because one of them is a 3-year-old child, he's going to take up a whole seat. You can't put 3 kids in one seat. I guess you could, but you're not supposed to. So 63, just keep going down the list and answer all of those just like that. This is the easiest part. 5 times 1 point. You'd be surprised how many people screw up this part though. So do this part right and do it first. 5 times 1.2. Use a calculator to make sure you do it right. Okay. And then 20. And I do want you to show your work over here. So literally type in what you're doing over here. Okay, I'm not going to go through every single one of those because I happen to know, I do want you to go through every single one of them, but I happen to already know that, and I'm just going to scroll through all of them, 45, 3, 27, 200, that's a large one. But I happen to know just by looking at all of those, 256, that the first one does happen to be, because I wanted to make it easy on you, the first one does happen to be the company with the greatest needs. So we're going to allocate them first. In other words, they're going to fill up the first part of the chart here somewhere. So let's answer this. Company ranking is number 1. We're number 1. Binary net mask. How do we calculate the binary net mask? Remember how I did it in class? We take the 600 plus 3. We always add 3. So, and we'll back up. What power of 2 is greater than or equal to 603? What power of 2 is greater than or equal to 603? You could do that. You could figure that out with the calculator, or you could go look that up on the internet, or you could go ask Google, what's 2 to the 5th power? 32. What's 2 to the 6th power? 64. What's 2 to the 7th power? 128. What's 2 to the 8th power? 256. What's 2 to the 9th power? 512. Still not big enough. What's 2 to the 10th power? That equals 1,024. So that's big enough. It's bigger than 603. 512 wasn't enough. So the 10, that thing that I wrote right, that 2 to the 10th power, that tells me the number of zeros in the net mask. There are 4 blocks here. How many bits are in IP version 4? Somebody type the answer for me. How many bits are in IP version 4? Nobody knows? You better know. It's 32 bits, 32-bit address space, 32 bits. Okay, so I take that 10 and I subtract it from 32. So I'm going to write 22 ones. 32 minus 10, in other words, is 22 ones. So here's the first 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Here's the next 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 16. And then 17, 18, 19, 20, 21, 22. There's my 22 ones. I need to finish with these boxes, 23, 24, because there needs to be 8 in each one of these boxes. So that's 1, 2, 3, 4, 5, 6, 7, 8. And this one's also 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay, you guys all follow me so far? Am I going too slow, going too fast? I'm not getting any responses in the chat window. Where did I get those numbers again? I pulled them out of the air. Ella, the way I got those numbers is I got the 600. Do you understand how I get the 600? With my projected needs, I took that 600, I add 3 to it every time. That's because that's the formula. what power of 2, here, let me blow this up a little bit. It's probably a little small. What power of 2 is greater than or equal to 600 happens to be 2 to the 10th power, which equals 1024. I take that power and I subtract it from 32. So there it is, 32 minus 10. And I wrote 22 zeros in these boxes. 8 of them went here, 8 of them went here. The remainder, 6 went here. That gives me the 22. And that filled the rest of the binary net mask with zeros. That should be pretty easy, right? No, yes? Now let's convert that into decimal. How do you convert that into decimal? Well, the easiest way is to just go use a binary to decimal conversion chart. I know I mistyped that. Or you could do the math like I showed in the classroom, but it's probably easier just to use a big honking chart like that. This is what most network managers do. Most of them cheat and use charts. Okay, so I'm just going to look for that entry, the 22 ones and 10 zeros. There it is right there. Oh, excuse me. 22 ones and 10 zeros is down here. There's 22 ones there. There's 22 ones and 10 zeros there. That matches, this line happens to match. There's the 1024. It matches what I'm seeing. Hang on the screen over here. So it told me on that page that that equals to, where did it go? Sorry guys, I'm trying to find it. It equals to a /22, or actually that one doesn't have the 255 on it. Excuse me, that's not a good one. Actually, let's go look at. Okay, there's a good one. There's the line we need right there. There's your decimal net mask. Yes, Joel, I'm recording this right now and I'm gonna post it on, I guess, YouTube so that I can get paid for it. No, I'm kidding. I'm gonna post it on wherever I can, maybe YouTube, maybe somewhere. But still, pay attention, please. So the decimal net mask is 255.255.252.0. According to that, right there, there's the answer. Make sure when you're doing this, I've already put the dots in. Okay, you're just putting the numbers in these little boxes. Can you see those boxes okay? Now at this point, I want you to do those 4 lines for everybody first, okay? Do the 4 lines for everybody first, then come back. After you're done with all of that, look at however you ranked the companies from largest, that number, to smallest. Here's number 1. Then you can start filling in the chart. Network address. Look up here at the chart. How much space have I got to take up? Well, these guys are going to take up a total of, what was my answer here? My answer in my work here was 1024. So these guys are going to take up 1024 spaces. Even though I only need 600, they're going to take up 1024. So I need to block all of that off. They're called my space book, so I'm going to do this. I'm going to put an M in every block on those first 4 lines. There's the 256. Now I'm up to 512. Here's 768. You see, guys, see what I'm doing? This is really easy. $1,024. Okay, so I just allocated. I basically shaded in the first 4 lines of this chart. And they can't be used for anybody else but myspacebook.com. So this shading in, or this allocation here that I just did, gives you your answers. There's the network number. There's the broadcast address down on the other end here, 127.9.3.255. Down here, that lower right-hand corner, because the next thing to do is define the upper left-hand and the lower right-hand corners of the rectangle. So the network address, 129.7.0.0. That's the upper left-hand corner. That's this corner right there, where that first M is, okay? Slash, what do I put for slash? So look at a silly chart there. There's your slash, slash 22. 22. Or the same as the number of ones. How many ones are here? I wrote 22 ones. Broadcast address, that's the lower right corner. It's going to be 129.7. What? .3, because I'm on this line, all the way down to the end. .255 right there. See the 255 right there? Easy, right? 3.255. Okay, you guys following me so far? Now at this point, I don't need to look at the chart anymore. I can fill in the rest of it. Where should you put your router? Where should you put your bus driver? Where should he sit? Remember that analogy? Bus driver should be sitting in seat 1 of the bus. Let's put him at 129.7.0.1. In other words, it's the first address right past that, right past the network address. What's the range of usable addresses for all of my PCs and servers, or all of my kids on the bus? 127.9.0.2 all the way through what? 129.7.3. Oh, it's scrolled off the screen there, 254, because I made the screen a little bit bigger. So it scrolled down to the next line, 129.7.3.254, not 255, because that's the broadcast address. It has to be the one just before that. Can't be .1 because the router's taking up that space. Okay, so you guys got that? Okay. Next box, maximum number of hosts in this block, not including the gateway router. That's really easy to figure out. You take that 1024 up here. And by the way, if you don't put any work notes in these boxes, that's fine. Type something though. Okay, type in something like this, like I looked at a chart. Okay, type something, otherwise it'll give you a 0 for that spot, or if you just put an X in there. But try to put some sort of notes in there. What's that 759? What are you saying 759, Rahi? Oh, you're guessing at the answer? You're close, not quite right. The answer is going to be maximum number of hosts. It's going to be that number, which is the answer up there. In other words, 2 to the 10th power minus 3. 1024 minus 3. That's the maximum number of hosts I can have in that range. 1021. That's the correct answer. How many addresses were wasted? That's the 1021 minus the original needs. What was my original needs? Right there, 600. Equals, what's 1,000? What's 1,021 minus 600? 421. Okay, so that's the answers to company number 1. Want to do the next one? Okay, so I'm doing your homework for you, but that's okay. As long as you guys are learning this, and as long as you do it on your own, the only way you can really learn this is to do it on your own. So I'm hoping that, and you guys got to promise me that you will do this on your own, that you're not just going to regurgitate whatever I'm putting in the video here. The company with the next greatest needs, let's scroll through here. I can probably just kind of get, well, I mean, I know because I wrote this freaking stuff, so I know. 12, 45. There's tiny code. They only need 3. Abracadabra needs 27. 200, excuse me, 256, and they're the last one. So yeah, these are the number 2 guys. 256 right there. Projected needs. What is 256 times 1.25? Divided by 6 times 1.25. 320. Okay, binary net mask. What power? 2 to the what power is greater than or equal to 320 plus 3, or 323? What's the answer? That's right, 2 to the 9th power equals, what does it equal? What's 2 to the 9th power? That's right, it's 512. How did you figure that out? Did you do it in your head? Did you memorize it, or did you go look at that chart? You're a computer science major, so you probably know 2 to the 16th power, right? What's 2 to the 16th power? Oh, come on, you gotta know. And you're not a real programmer, sorry. Dun, dun, dun. No, I'm kidding. You're fine. Okay, so the binary net mask is 9 zeros, and what's 32 minus 9? That's the number of ones. And if you prefer, you can start over on the right side here. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 zeros. You can only have 8 bits of anything in any of these boxes. Then there's the 9th zero. Then I got to fill the rest of it up with ones from the left. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's the answer to that. Decimal net mask. Here's a shortcut. If it's got all ones in it, it's going to be 255 in decimal. 255.255. And then if it's all zeros, it's going to be 0 in decimal. That's going to be 254. And the way I know that is because you could either look at a chart, or you can know, well, that's the ones place. 255 minus 1 is 254. I charted it. Just write something in those boxes. Okay, network address size. Now we're going to go up and look at our chart. How many lines do we need? 512. In other words, we need, in this chart, and that was 2 to the 8th power company, right? Two to the 8th power company, we're supposed to use a number 2 to represent them right there, number 2. Sorry, trying to highlight. So 512, we need 2 lines there, 2 whole lines, because only one line is only 256. So we put 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Or you can put a bunch of 2s if you wanted, but you know, you're trying to give me the idea here. Stop there. There's our net mask and our broadcast address range. That's the 2 lines that we just used up for 2 to the 8th power, so you can fill out the rest. Remember that. 129.7.4. Just keep that in your head for a minute. 129.7.4. Scroll to the bottom. Network address 129.7.4.0. That's the upper left-hand corner. It's a /23. Why is it a /23? Because it's 32 minus 9, right? There's the 9. It's 32-bit address space. 32 minus 9 equals 23. That's why that's there. Broadcast address is the lower right-hand corner. It went all the way to the second line, 5.255. Excuse me. We doing okay? Please pray for me that I don't have anything. I don't think I do, but you know, occasionally I go out. So, router address. Where do we put the router? 129.7.4.1 because that's a good place to put it. Range. Or should we? What is our range? (129.7.4.2) all the way to 129.7.5.254, not 255. Network managers make that mistake all the time. Maximum number of hosts in that range. How many number of hosts? 2 to the 9th power was 512. And we need to subtract 3. We subtract 3 because we added 3 in the beginning here, because one of them is the network address, one of them is the broadcast address, and one's the router address. So that equals 509. So that's the answer for that. We can have 509 servers in that big range. That's a nice big range. Amount of wasted addresses. What's the original needs? It was 300, excuse me, it's the 509 minus the 320, which equals dun, 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 dun. 189 wasted addresses. First of all, is that right? 256 times 25. Let me figure that out real quick. Yeah, 320. I thought it was 323 for some reason. Oh, that's because somebody put that on a test once and it burned into my brain. Okay, so that's the answer to number 2. Let me do just a couple more. What I want to do is I want to get down to one that only takes up half a line or a quarter of a line. Okay, because so far this is easy, or at least I think it's easy, because they're taking up entire lines. Okay, in other words, we've got a big 4-lane wide semi truck, and then we've got a little bit smaller truck, and we've used up a good chunk of our chart already. Next biggest company, I think, had a need for 200 addresses. There they are. Nothing but net, nothing but .net. Needs 200 addresses with 25% growth. So let's see. So that's 200 times 1.25, or what's that answer? You guys better know that right off the top of your head. That's 250. Oh, excuse me. Ranking 3, 250. Binary net mask. Two to the what power is greater than or equal to 253. What's the answer? 2 to the somebody other than the CS major. How come nobody has their video on? I can't see you. 2 to the 8th power. Because that equals, excuse me, yeah, that's right. 2 to the 8th power equals 256. You could have used your calculator, or you could have used a chart. So that's 256. The 8 implies that there's going to be 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. The rest of this is all ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. When you're filling this out, by the way, very carefully count the number of ones you put in there. If you put in 7 or 9, it's going to count off. Even though I kind of, and I'll figure it out. I'll go in there and look at that. Decimal net mask. This one's easy. 255.255.255.0. That happens to be what's called a class C. Network address. Let's look at the chart. That's going to be one line in the map. Where should we put them? We're not supposed to waste space. So we're going to put them right there. In 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 blocks of 16. So the network number is that 129.760 all the way to 6.255. Easy, easy, right? What's the slash notation? Somebody tell me. What goes in this box right here? Is anybody there? Hello, wake up. Is everybody gone? Yes, thank you. CS major. Thank you, KALED. Still here. Well, okay. So do you understand why that's 24, Ella? It's the 8 minus 32. 32 minus 8. Okay. Just want to make sure I still got your broadcast address. That's the last lower right corner. Router address. Let's put him at 6.1. Range 6.2 to 6 all the way to 254. Maximum number of hosts, we can have 253 because it's 256 minus 3. Wasted addresses, that's going to be the 253 minus the original needs of 250, which is only 3 addresses. So we made a really good use of that range. We only got 3 wasted addresses, or we've got very little space to expand for that company. So I would probably keep an eye on those guys. Next, let's do the next one because I want to do one that uses only maybe half a line. And then I'm going to quit because we're 2:30 to 4. We're cutting way deep into chapter 8 time here. That's okay. I think this is important, right, guys? I mean, do you appreciate that I'm doing this? I hope you do, because this is 25% of your test. So we'll pay attention to it. I don't remember from memory which one it is. So let's just look here. We've already done that one. Oh, no, we haven't done that one. Let's see, it's not 55. 120, it's probably Cougar Town. And yeah, we already did nothing but net. Yeah, it's Cougar Town. Cougar Town's number 4. Go, mommy. So Cougar Town's number 4. Isn't that sad that this is going on? You know, we were probably going to go to the Final Four. University of Houston Cougars this year. We have a great basketball team this year. So let's hope we get a chance to replay that sometime in late 2020, I guess. It'll be called November Madness, I guess. Work notes. Cougar Town was 150 binary net mask. What power of 2 is greater than or equal to 153? 150, and that would be, let's see, is 2 to the 7th big enough? Not quite big enough, unfortunately. 2 to the 7th is only 128, so no, we got to go to 2 to the 8th. So this one's actually also going to take up a whole line. Okay, I'm not going to fill all that in, but I'll fill the chart in just to get rid of Cougar Town here. So Cougar Town is going to take up another whole line because we had to waste, excuse me, I backed up. We had to waste an entire class C just for these guys, even though they only need 100. Oops, that's too many. You're never going to scroll off the end. You can't scroll off the end of this big ferry boat, okay? Even though they're going to stop somewhere right about here, not there, but they're going to stop somewhere within there, and they don't need to use the rest of that space. But you can't do this. You can't just go, okay, I'm going to stop here and give this to somebody else. Cannot do that. Why can't I do that? Because it doesn't fit. In other words, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks that I've allocated for Cougar Town. 9 is not a perfect power of 2. 8 is, 9 is not, 10 is not. The next power of 2 is 2 to the 4th power. Excuse me, 2 to the 8th power, or 16 blocks, in other words. So I have no choice. I have to allocate this entire line all the way up to the next valid power of 2. Okay, let me just do the next company, and you guys could fill that in with this. I want to get to the next company that has less than a full class C. I think it's Ejecta. Let me check. It's not Go Mommy. Oh, it might be Spambot. Spambot. What does Ejecta need? Nope, it's Ejecta. Okay, so Ejecta. 50 addresses. So they're going to rank 5th. 50 times 1.25 is 62.5 or 63. Never, ever, ever put 62.5. If I see 62.5, I will fail you from the class. If you ever put 1/2 of a computer or 1/10 of a computer, if it's 62.001, if the answer is that, it's 63. Always, always, always round up. Binary net mask. What power 2 is greater than or equal to not 63, but 66, because it's 63 plus 3. 2 to the 8th power is too big. That's 256. 2 to the 7th power is 128. That's pretty big too. That might be too big, but 2 to the 6th power is only 64. It's not big enough. So it's 2 to the 7th power. In other words, 7 zeros. 1, 2, 3, 4, 5, 6, 7, and the rest of it is ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The decimal net mass is 255.255.255. Excuse me. I feel like I do more talking doing this. A .128. You could go look at the chart for that. I promise it's that. Network address. We're doing Ejecta, right? Ejecta Technologies. That's my company, by the way. Why 66? Why did I do the math with 66? Is that what you're asking, KALED? Because I'm just following my formula. My projected needs were 63, but you always have to add 3 to your projected needs. Only in the calculation, not in, 66 would never go there, and several students make that mistake, by the way. Do not make that mistake. Do not put 66 there. The projected needs as far as the customer is concerned is 63. That's given. 50 times 1.25, 63. You as a network manager need to remember, oh yeah, I've got to add 3 to my calculations because one number is a network address, one number is a broadcast address, and one number is the router address that they have to connect to the internet. That's where the 3 comes from. Got it? Okay. So Ejecta is going to take up only half of these blocks. Okay, because I need to only go over to 128 or 2 to the 7th power to there. So they're going to take up 1, excuse me, I hit the tab, hit the 2, 3, 4, oh no, I took my caps lock off. It doesn't matter if you do upper or lowercase, by the way, on the 2, 3, 4, 5, 6, 7, 8. And then the rest of that's going to be available for anybody else to use it. 2 to the 8th power. Oh, excuse me, in this case, 2 to the 7th power. 2 to the 7th power, only 8 blocks, only half that line. You guys see it? Why I'm only using half that line? From 0 to 128, right there, the lower right-hand corner. I'm on line 7. So 7.0 all the way to 7 dot, not 128, and several students make that mistake, it's 127. If you were to put 128, you'd be in the next range over, it's 127. You gotta back up, you gotta hop back in to your range because we started counting at 0. What's that slash notation gonna be? Look on the chart, it's gonna be a slash 25 because there was 7 zeros. That's, in other words, that's 32 minus 7 equals 25. Is this getting easier for you guys? You guys understanding this now? How about you, Al? Are you understanding this? KALED, you understanding this? All right, now, should I let you go on your own and try to finish the rest of it? Yeah, you do need to do it yourself, Joel, exactly. And I promise you, even if you're lost right now, as you start doing it, and if you followed along what I did today or you watch this video later, the light bulb will click on after about the 4th or 5th company and you'll realize, oh, okay, I understand what's going on. I promise you, a light bulb will literally click off in your head or click on in your head. And you'll realize what you're doing. It's really pretty easy. The online submission is available right now. It's already there. That's how I'm able to fill this out. You can submit this as many times as you want. Okay, so in other words, go ahead and do the whole thing, even if you're not 100% sure what you're doing. How do you know how many spaces to allocate? Again, it's given right here. This company told me we need 50 addresses and we may grow by 25%. So that's just a simple math calculation. 50 times 1.25 equals the 62.5. Then you do this little calculation right there. 2 to the what power, the little caret sign means raised to the power. 2 to the what power is greater than or equal to their needs that they gave me plus 3. That's how you figure out. You only see the PDF version? Are you guys only seeing the PDF version, by the way? They should both be there. Okay, I'll double check. I may have a date restriction on this. If I let me fix that then. So I'm done with this for right now. So I'm going to go back. Actually, no, I'm going to do it that way. I'll do save and submit. Oh no, I've only got a 50%. Man, I sucked. Okay, so all right. Anyway, so let me go back to the assignment. Let's make sure that that assignment is available for you guys. And I apologize if it wasn't. Oh, you're right. It is hidden. I totally apologize for that. Let me edit the options here. You should do the PDF version too. Okay, for some of you, it's more helpful to print out a piece of paper and to tear out little scraps of paper and literally use those like you're placing little cars on a map. Okay, some people are more visually, some people prefer to do that more physically and visually. That's how I learned how to do it. I literally cut out little pieces of paper and moved them around on a map. Played with blocks basically and understood it. What do I need to change here? I need to change, make it available to students, add a new announcement. Sure, number of attempts. I'll give you guys 3 tries on it, okay? I know I said it, well, here, I'll give you 5, okay? If you can't figure it out in 5, then you're in the wrong line of business. Last graded attempt, there's not gonna be a timer on it, display after, and take that off. There's no password on it. Submit. Now you should all be able to refresh your Blackboard and see it. Okay? Somebody go check, make sure you can see it, just so that I'm not called a liar. Okay, good. All right. Let's, we finished all of chapter 7, we got into chapter 8, right? I wanted to spend a little bit of time and show you draw.io, but we'll just do that on Monday, because that's an assignment that I want you to do that's due by the end of the semester. And it's fun to play with, but it seems like a lot of you haven't done the subnetting assignment yet. So complete this first. See if you can get that done this weekend, guys, and get it turned into me. Because the sooner that you turn it in, and like I said, that automated version, the 1.0G, will auto grade itself. And so it'll give you a grade. So if you turn it in, you get a 75. Obviously, you did something wrong. Go back and look at your charts to figure out what you did wrong. Print out the PDF version. Okay, so chapter 8. Give me 1 sec. If you want to check out now, you can, but you're going to miss a little bit about backbone network. I just want to finish up here. Seeing on my download junk. Okay, chapter 8, blah, 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 blah. Backbone network. The thing from last class, and I don't know if all of you were here last class, but what I wanted you to remember from last class was what the difference between layer 2 and layer 3 or managed switches are, what a VLAN is, a virtual LAN, which we haven't gone into much. We'll talk about that more today with the few minutes that we have left. But these icons are important. Remember that that is an icon for a layer 2 switch. That's an icon for a VLAN switch. This is an icon for a router, which works at layer 3, not layer 2. Backbone networks have 3 different layers: access layer, distribution, and core layer. The access layer is the layer that's closest to you. The distribution is the layer between you and the rest of the network in the building, and the core layer is the layer that's furthest away from you as a user. It connects buildings together, or it connects an enterprise together, and it's the final layer before the network that you own hits the internet. Backbone networks are typically owned by the entity that's using them. That's how we determine the scope difference between a LAN and a backbone network and a WAN. Most organizations own all of their own LAN. Most of them own all of their own backbone network, but almost nobody owns their own WAN. Large companies do, like AT&T or communication companies do. Access layer closest to you, distribution, and core layer, the next 2 hierarchical layers, further away from you. This term, main distribution facility, this is where the cable goes to. In a closet like that, that might be an example of a main distribution facility. In a network closet somewhere in your building or on your floor, or if this is your home, it's where the little router sits on your desk. That's your MDF, wherever that is. That's the graphical representation of that picture. I think I showed you guys that last time. Notice that these are not daisy chained. These 4 switches here are connected to this switch, which might even be a layer 3 switch, which goes to the building backbone, but they're all connected on their own individual ports. Here, those switches ultimately connect to a distribution layer switch. Down here in this example, all of the 3 floors of this building go down to a larger, faster, more powerful switch in the basement, which we don't put anything in the basement here in Houston. We learned that not in Hurricane Harvey, but in Tropical Storm, what was it called? Allison? Was anybody around for Tropical Storm Allison? I think that was it. Wasn't that the name of the one that was in year 2000? I think it was Allison. In the year 2000, Houston had a flood. It was almost as bad as Harvey. Wasn't quite a hurricane. It was like just under a hurricane, but it was about 40 inches of rain. Well, it flooded the university. We used to keep all of our stuff, all of our backbone and core layer stuff in the basement of all the buildings. We don't do that anymore because it all went underwater and got destroyed. So all of this stuff is really like on the first floor or even the third floor. And then here's the router that connects us to the campus backbone. This is almost always a fiber connection. Summer of '01, thank you, Rahi. You're old enough to remember, I think, right? So was it pretty devastating for you? Did you lose cars? Did you lose a house or anything terrible like that? It's pretty bad. I had just moved into a new house and we didn't lose any houses, but I lost a car. So anyway, routed backbones. You don't have to use intelligent switches. These could all be dumb layer 2 switches, and we don't have to use a router. This could just be a switch going to the campus backbone. But again, if all of these are just switches, all of the broadcast traffic at layer 2, not layer 3, DHCP and ARP and all this other traffic that's on a layer 2 network in the MAC layer is being broadcast throughout the network to your wireless devices, to all your LAN devices, and it doesn't need to go on the campus backbone. So usually we stick a router, which acts kind of like a firewall, and it only passes layer 3 IP traffic in and out of a network. There's less traffic going on at layer 3 than there is at layer 2. So here, when we're talking about a switched backbone versus a subnetted or a routed backbone, is the advantages to doing that is we can segment the LAN at layer 3, but it does slow things down a little bit. And that's because this router at layer 3 has to be doing a little bit of checking of all of the IP packets. He's got to check to see what's, not what's in the packets, but how they're addressed. Also, these things have to be programmed, pre-programmed. So it slows your networking down by a little bit, but it keeps all the garbage that's in this network, in this building here, from going out onto the campus backbone, like printers that are advertising themselves. Hey, I'm a printer, I'm available here, come print to me. Guy in another building doesn't give a crap about whether you've got a printer on the 3rd floor in office such and so, because he doesn't use that printer. He's not in there, so he doesn't need that extra traffic. We use routers to separate layer 2 traffic from one building to another. Just remember from this, routed backbones, the only real disadvantages are it slows down the total throughput of speed of networking a little bit, a couple percentage points. In other words, and the only time it's ever a problem is if there's a guy in this LAN that needed to send a file to a guy on another LAN, another building over here, through this router. The traffic's going to be a little slower than if he was sending some files from this LAN over to this LAN and we're just on a switched network. Okay, so that's the only real disadvantage. A little slower, more expensive, and it says it's harder to manage, and that is true. It is harder to manage only because somebody had to pre-program that router. That's not a firewall in this case. This is not private IPs and that's not public IPs over here. That's public IPs and that's public IPs. This is just a router. There's a certain range of IPs over here and a certain range of IPs over here, and this router bridges those two together, connects those two together. How are we doing on time? Okay, we're getting close. Okay, here's a larger, expansive drawing of what a backbone might look like at a university. Each one of these little sub clusters here might represent a building in a network. Each one of these little pieces represents a LAN in that building. So this is a network layer switch that is connecting to a LAN. This is, or it might be considered, we consider this an access layer switch. There may be other switches. So we'll say that that's an access layer switch. There's the access layer backbone right there. You're not talking directly on that. So that's an access layer switch. You are physically connected to that. Here's the distribution layer switch, which all these access layer switches connect to. And then that distribution layer switch talks to a router, or maybe another switch, but it's a layer 3 switch, which works like a router. And here's your distribution layer network, your backbone. And then from that router to the core router that gets me out to the outside world, this would be like, this core router would be over in the computing center building off of Elgin next to channel 8. That's where our main internet connections come in, okay? These routers, it's really just one switch, or actually at this level, they're in the PGH building in the middle of campus. Each of these lines here, these are going over to the PGH building, and then all of these lines go over to the Elgin building, the computing center building. These are, in our case, and in most cases, these are going to be very high-speed networks. These have to be higher speed. So these are probably fiber connections. These are probably copper 1G connections, or even wireless connections here. But you're going to end up drawing, or you're going to end up wanting or needing to draw a diagram like this in draw.io. This is a good example of one to draw with draw.io. Okay, I'm going to finish off this video in this session by just mentioning virtual LANs and what a VLAN is. Virtual LANs. Routers can segment networks based on physical locations, but sometimes devices in physical locations need to access the same LAN resources. Let's say, for example, let's go back to this drawing, okay? Each one of these connections up here at the top here is a patch panel, and they go off to a specific office inside of this building. Let's say that the office that's connected on port 1 here, or let's say that the first 8 ports here are in the finance department, okay? And all of those offices are contiguous, they're right next to each other, so it made sense to put all those right next to each other in this patch panel when the wiring was done. But now let's say somebody from the finance department moves offices and they're now on a different floor even, or they're in a non-contiguous space and the cable going to their office is over here on one of these ports over here, and it's feeding into not this bottom switch, but this switch up here. We still want him to see at layer 2 the printers and all the other shared devices, and we still want him to get a DHCP address from the finance LAN. But this switch might have been originally dedicated to the accounting department LAN. So with VLANs, if these switches are VLAN capable, they cost a little bit more to do that, but with a VLAN capable switch, you can literally log into them and they're programmable. And you can program them based on various different criteria. In other words, I can log into these 2 switches and I can create a VLAN, and I can say, okay, VLAN 1 equals the accounting network and VLAN 2 is the finance network. All of the frames that I'm going to send in and out of this first switch are going to be tagged as accounting frames. And I can say, well, if anybody that was on this switch is now in a different department on port 5, for example, I'm going to say all of the frames coming into and going out of port 5 are no longer in the accounting network, they're in the finance network. I assign a different number to them. It's called VLAN tagging. I'll give you another little picture here. Here's a simple 8-port switch example. VLANs are numbered anything from 1 to 4096. That's what we decided to use for VLANs. Some of the VLAN switches are smarter and you can name the VLANs. In this example, we've decided to say, okay, VLAN 10 is going to be comprised of ports 1, 2, 4, and 7. Oops, there goes my mouse. Hope he didn't die. Nope, he's still alive. Oh, where am I? Oh my God. VLAN 20, and this could have very well been VLAN 1 and 2. We just separated it into VLAN 10 and VLAN 20, or this could be named accounting VLAN, finance VLAN. In VLAN 20, I literally log into the switch and I program it, and I say port 3, 5, 6, and 8 are on the VLAN 20, not VLAN 10. So what happens now is only traffic with IP addresses will pass indiscriminately between these computers. So if this guy here, if he's broadcasting traffic out, DHCP traffic, for example, or traffic, network traffic, like I've got a printer attached, it's only going to go at layer 2 to 2, 4, and 7. It's never going to be seen by 3 or 5 or 8. So VLANs clean up our network a little bit, essentially, or what it basically does, another way to think about it is it takes a physical device like an 8-port switch and chops it in half into 2 4-port switches. It's really a nice thing to do. It's a nice thing to have, VLAN capability, especially if this is a 48-port switch. If this is a 48-port switch and I needed to break it up into 3 or 4 physically different groups, I can do that with VLAN tagging, or VLAN programming, I should say. I can log in, and it's literally a map that you create. You can say ports 1 through 8 is this, or 1 through 8 and 10 and 23. It depends on the OS of the switch. VLAN switches cost about twice as much. A little 8-port switch you can buy for 20 bucks. A VLAN capable 8-port switch is going to be at least 40 or 50 bucks. Okay, so it's almost 4 o'clock. I'm going to go ahead and stop there, guys, okay? And then we'll pick up the rest of chapter 8 on Monday, or actually we might, and I don't know how you guys feel about this, but we should probably have another class to catch us up because we had 2 weeks of spring break. How do you guys feel about that? Probably not good, right? I haven't been given dates as to when the official end of the semester is. So I have to assume that the official end of the semester is still officially, May 30th or whatever it was on the syllabus. Do you want to do it now? No, you will. So what we might need to do, and I'll keep you guys appraised, we might need to have a class on Friday or Saturday a couple of times to catch us up. I'm going to talk to other professors. I'm going to talk to the department chair. I want to see what they are doing because I think it's important for us to stay on track. There's a lot of material that we're going to end up missing because of this COVID-19 thing that I think is very important for you guys to know. Otherwise, I would not feel comfortable telling a potential a company of a potential hiree of a student, for example, that took my class, are they pretty well versed in networking? It's like, well, no, we had COVID-19 and they missed 4 or 5 classes. So I don't know, probably not. So I prefer to have you guys get to see all of the material of this class all the way through chapters 12. So I'd like to stay on track. I hope you guys would too. So I'll let you know as soon as I can. I'm going to, and regardless of whether or not you can attend all the meetings here, I'm going to start posting these. I'm going to either put them on TikTok or what's the other one? Or what's the original one? I'm having a mind blank here. YouTube or whatever the appropriate platform is. We have, like I said, we haven't been really told yet. I think Parks is putting his on YouTube. Snapchat. I don't think I can put them on Snapchat. I don't think Snapchat lets you make an hour-and-a-half long video. But yeah, I may just do a puppy filter. Great, yeah. Okay, so let me stop sharing here, and I'll see you guys. And if you want to, for those of you that want to do this again, join the next class. I'm going to do another one of these right now for the 4 to 5:30 class. If you want to sit in on this again, do it all over again. See you guys later. You're welcome.